because there is already 8 electrons filling the highest main energy level of each noble gas. The noble gases have already reached stability. Therefore, they do not undergo many chemical reactions in order to reach new levels of stability. The periods of the periodic table are determined by electron configuration. The length of each period is determined by the number of electrons that can occupy the sublevels being filled in that period. The period number of an element determines the highest energy level of that element. For example, carbon is located in period 2. Because of this, 2 is carbon's highest main energy level. The periodic table can be divided into 4 blocks: 3s block, the p block, the d block, and the f block. The s block is composed of groups 1 and 2 besides hydrogen. The p block is composed of groups 13 to 18 besides helium. The d block is composed of groups 2 to 12. The f block is the lanthanide series and the actinide series. The name of each block is determined by whether an s, p, d, or f sublevel is being filled in successive elements of that block. The elements of the s block are chemically reactive metals. In fact, they are so reactive that they are not found in nature as free elements. They are found only in compounds. The elements of group 1 are more reactive than those of group 2. The elements of group 2 are harder, denser, and stronger than those of group 1. The elements of group 1 are known as the alkali metals. The elements of group 2 are known as the alkaline earth metals. The d block elements are composed of groups 3 through 12. The d block elements are metals with typical metallic properties. These d block metals are referred to as transition elements. They're good conductors of electricity and have a high luster. The p block elements are the elements of groups 13 through 18. The p block elements together with the s block elements are called the main group elements. At the right hand, the p block contains all the nonmetals. All 6 metalloids are also contained within the p block. The metalloids in the p block elements are separated from the metals by the metalloid line. Any element besides aluminum and polonium that lies along the metalloid line is a nonmetal. The number of electrons in the outermost main energy level of a p block element is equal to the group number -10. For example, phosphorus is a p block element and a nonmetal. Because it belongs to group 15, there is a total of 5 valence electrons in its highest main energy level. The elements of group 17 are the most reactive nonmetals. These group 17 elements are known as the halogens. The reason for their high reactivity is the 1 electron missing from the 7 electrons in their outermost energy level. The lanthanides and the actinides are the f block elements. The first 4 actinides are naturally occurring. The rest of them are laboratory-made. All of the actinides, however, are radioactive.